So hey guys, welcome to my channel. Topic for today is going to be lead code number 875, that is Koko Eating Banana. So this is video number 14 of binary search playlist, and today we're gonna learn binary search on answer as a topic. So let's get started. Okay, so I'll just read the question out and then I'll explain the question better with an example. So Koko loves to eat bananas. There are n piles of bananas. The ith pile has pile I bananas. The guard has gone and will come back in HRs. So the zeroth pile has 3 banana, first pile has 6, second pile has 7, and third pile has 11 bananas. Okay, and there is a guard which has gone and will come back in HRs. And Coco can decide her banana per hour eating speed of K. This is very important. Each hour she chooses some pile of bananas and eat K piles from that pile. So each hour she has to complete bananas from that singular pile. She cannot mix two bananas from two piles. Okay, that is also one important thing. Okay, if suppose she has the speed of 2, she eats 2 bananas from this pile in the first hour. In the second hour she has to eat from the same pile. That is, if the pile has only 1 banana left, she has to utilize that entire hour to complete that pile. Okay, so that is the important thing. Let's go to the explanation part of this now. So we have taken this example 3, 6, 7, 11, and let's say the guard is going to come back in 8 hours. So what are we actually trying to find? So you have Coco, and her speed of eating banana is, let's say, 1. So let's say the speed of eating banana is 1. So what we are actually saying when we say speed as 1 is she can only eat 1 banana in 1 hour. Okay, so if the zeroth pile has 3 bananas and her speed is 1, she will require 3 hours. Correct. So to complete this out, she will require 3 hours. Okay, and in the second pile you have 6 bananas, so she again will require 6 hours to complete all the bananas. But if the guard is going to come back in 8 hours, so she ate 3 bananas from pile 0, she ate 6 bananas from pile 1, but now guard will come back and catch her red-handed. So it's not going to work for Coco. So with the speed of 1, if she tries to eat bananas, she will get caught. Okay, so we cannot use speed as 1. What if her speed was 2? What if her banana eating speed was 2? So from the pile 0, she can eat 2 bananas in an hour. Again, the remaining in another hour. So she requires 2 hours. 1, 2. From the pile first, she will eat first 2 bananas in third hour, in fourth hour, and fifth hour. So first pile is done. 0th and first pile is done. In the next pile, the second pile, she will eat uh, 6th, 7th, and 8th. Okay, but this will remain. The last banana will remain. Okay, so and the hours will be over. See, we have taken 1, 2, 3, 4, 5, 6, 7, 8, and she cannot eat any more bananas, or the guard is going to come back. So what we're gonna do is, this speed is not going to work. Let's clear it out again. What if she ate with the speed of 3? Will that work? Let's see with the speed of 3. So she ate all 3 bananas in 1 hour, so she only required 1 hour. For this, she only requires 2 hours. So I'm drawing it like this. This is the second hour. This is the third hour. This is the fourth hour. This is the fifth hour. And this is going to be the sixth hour. Okay, fourth, fifth, and sixth. So the last pile is remaining, but she can only eat 3 bananas in 1 hour. So this and this. So with the speed of 3 bananas per hour, she cannot completely eat all the bananas. Okay, these bananas will be pending. So with the speed of 3, it's not going to work for her either. So let's get back. Let's try with the speed of 4. Will that work? Okay, let's say. So in 1 hour she can eat 4 bananas. So this will be eaten in 1 hour. This will be done in second hour. This will be done in the third hour. This will be done in the fourth hour. This will be done in the fifth hour. This will be done in the sixth hour. This will be done in seventh hour. This will be done in eighth hour. She can complete eating bananas. All the bananas she can eat with the speed of 4. She requires minimum the speed of 4 to complete all the bananas, and guard won't catch her. So I wanted to showcase that using linear search as well, we can solve this problem, but there is a more intuitive way we can solve this. Okay, and the concept is pretty fun, pretty good, and it is used in a lot of questions, and it has been repeated multiple times. The concept is binary search on answer. So what you have is, before we had this number line, let's say on general cases we had this number line, and we tried in using linear search that on first, on second with the speed of 2, with the speed of 3, the speed of 4, with the speed of 5, and we got our answer at speed number 4. That is, the 4 is the minimum speed at which Coco has to eat bananas to complete all the piles. That is what we got from the brute force. Okay, the brute force way was check on every single speed. Okay, and at whichever speed we got the answer first, that is going to be the answer. Okay, that was the brute force. But what we can do is we can think that what is the minimum and maximum speed that Coco has to eat the bananas and draw it in on a number line. Let's just say the whole concept of binary search on answer is nothing but a number line. You have this number line. Okay, you set the starting and ending indexes. But what are the values of starting and indexes? Generally, the starting is the least valid index, you can think, least valid value. So Coco cannot eat bananas at the speed of 0. You will never reach the answer like that. So the starting point has to be more than 0. So I have to take it as 1. But what about the ending point? What is the highest speed that Coco has to eat? The maximum she can eat. That is, let's say she has to complete this array, right? She has to complete 3, 7, 3, 6, 7, 11. So in this is the lowest pile and this is the highest pile. So she has to eat at this speed at highest point to complete all the bananas. She has to eat at this speed. Okay, so by that we set the minimum and maximum. Now the next thing is, how do we find answers better in a better way? What we can do is we can calculate mid. So suppose this is where the mid we got, and I'm going to just teach you the concept of binary search on answer. So what it tells you is, you try to try to find the answer that can Coco eat the bananas using this mid. Okay, with this particular mid value. If she's able to eat with this value, then we can be sure that she can surely eat on the right side. Okay, let's say the speed of Coco was 6. Suppose the mid was 6, and she's able to eat at speed 6. She will surely able to eat at 7, 8, 9, and 10. Okay, but if we found answer, if we are able to say that she can eat at mid, we cannot say that she can eat at 2. Okay, so we have to test it for that as well. So let's say Coco was able to eat the bananas at speed 6. So we actually eliminate the whole right side of this. Okay, and we again search for a better answer. That's why this mid will become E, and we again find the mid. Okay, whatever value of mid we get, let's say that at this point Coco was not able to eat bananas or at this speed. Let's say the speed was 2, I suppose. Okay, so surely if she's not able to eat at speed 2 and get the answer, surely she can never eat at speed 1 and get the answer. So this whole left side will be eliminated. And you have to set the starting index as mid plus 1. Okay, so this is where the starting index will point at. So that is how you're going to reduce the search space on binary search on answer. So let's just do a quick dry run on a particular example and then just do the coding part of it. So the whole point of binary search on answer is just a number line. You fix points, the starting index and ending index, and you check the mid against a certain condition. At this point, it is can eat. We are calling the can eat function only on the mid part. Okay, that is the speed at which Coco is going to eat the bananas at. We set the maximum speed as 11. We set the minimum speed as 1. So we perform the can eat call. So let's just see the example now. So let's say that this is a number line that I have taken, where starting index is 1 and the ending index is going to be 11. Okay, I chose this number from the array we had, that is 3, 6, 7, and 11. Okay, so the 11 was the maximum, so that's why I've took the 11 in the number line. Okay, so what we can do instead of this is, instead of doing a linear search that going one by one by one by one, okay, this is what we were doing previously. We took 1, then we went on 2, we went on 3, we went on 4, and likewise we went. And at number 4 we got the answer, right, in the linear search, and that's why we returned 4 as the answer. But this process could be eliminated if we think in terms of number line and we do binary search on it. So what you do is you select the mid, you calculate the mid, that is 1 plus maybe 11 by 2. You got mid as 6. You place your mid as right here. Okay. And insert, and now you call the function can you eat, can Coco eat banana on this mid as 6. Okay. So we know that the 4 was the answer in linear search. So we are pretty sure that whatever answer after 4 we get is also the answer. Okay. So these are all valids. So first we got mid as 6. So we can say that can eat for 6 is going to return true. So Coco can eat bananas in 6. So what we can do is we can consider this as the answer, this as the valid answer, and we can eliminate the right side. Since whatever answer we get on the right will be more, right? So we can totally eliminate the right side. Okay. Without, we can eliminate the right side and bring the end index to mid. Just a minute. So we can eliminate the right side. We can bring the end is equal to mid. So this is where the mid is going to point, end is going to point. So we again calculate mid, and this time it's going to be mid is equal to s plus e by 2. It's going to be 1 plus 6 by 2. It's going to be 7 by 2. It's going to be 3. This is where the mid is going to point. We can call the function can Coco eat bananas on 3. The answer we will get is false. Since in linear search we know that if we got answer at 4, we are pretty sure we will never get answer at 3. Okay. So since we are not going to get answer on 3, we can eliminate the left side and the mid itself. Okay, so we will never get answer in this. So we have to move the starting index from here to here. Okay, so the starting index is at 4, ending index is at 6. So we calculate mid again. S plus e by 2 is going to be 4 plus 6 by 2. It's going to be 5. So we call the function can eat on 4. So the answer we're going to get is true. Since everything after that, these arrow indicated that everything was true. So true, we got true. So Coco can eat bananas at speed of 5, not 4, but 5. So this is where the mid was pointing. This is where the mid was pointing, and she can eat bananas with a speed of 5. So we can eliminate the right side. We can bring the end pointer to, this is where the end pointer is pointing. We calculate mid again. Okay, we calculate mid again. So mid is going to be s plus e by 2, 4 plus 5 by 2. It is going to be 4. So can Coco eat banana at speed of 4? The answer you're going to get is true. Okay, so if she can eat with a speed of 4, we are again going to take the end pointer. So this is where the mid was pointing. We're going to take the end pointer to right here, right? And this is going to be end. This is wait. Okay. So the ending index, starting index are pointing at same point, and this is where we will stop the code. So let's just do the coding part of it. And I wanted to tell you that if you have array like this 3, 6, 7, and 11, okay, and we consider that the minimum speed at which the Coco has to eat is 1. Definitely we cannot say that Coco can eat at speed 0. Okay, it's of no use. So the minimum limit at which we have to check is the starting point is at 0. But what is the maximum point we have to check? Let's say in 1 hour Coco eats 11 bananas. Okay, so going more than 11 does not actually make difference. Like if the banana eating speed was 12, it again won't matter since she will able to finish the largest pile is at size 11. So going more than that actually adds no value. So the ending pointer, the ending index that we have to check for the range is going to be 11. And what is 11? It is the maximum of the piles. Okay, so if this much is clear to you, then let's just get started to the code. The linear search code first. Let's just do the linear search code first, then we'll do the binary search code. So let's say let's write a utility function bool can Coco eat with the piles p, the max r is max r, and let's say with the speed of k, we are trying to eat the banana. With the speed of k, she's trying to eat the bananas. But and let's say we are doing a linear search. So int I is equal to, the starting point is, let's say, 0. Then the starting point is, let's say, 1, and ending point is going to be the max element, the maximum, uh, the max speed at Koko can eat. That is going to be the max of piles dot begin and piles dot end. Okay. So for int I is equal to s, I less than e, I plus plus. So we are just performing a linear search at this point. We check if she can eat the bananas, that is piles. The max are going to be h taken from here, and this speed is going to be I. So if she's able to eat at this speed, then we can surely say this is the answer. Okay. And in outside we can return e as the answer, that this is the maximum, this is the speed that she will require. Okay. So let's just complete the can eat function. So we have piles. So we have to make sure that Coco goes through each of the pile and tries to eat with the speed k. Okay. So initially she has spent 0 time. So the r is 0. So for piles, auto pile in piles. Okay. So if, and we have to say that r plus equal pile by k. So she will require that many hours for this particular this pile to complete. But what if the r is something like r is 8 and her speed is going to be 3, k is equal to 3. In that case, in the first hour, it will be, she will eat 3 bananas, then 2 bananas will be left over, right? So you have to also consider that part. So if r, no, if pile mod k equally is not equal to 0, then we can surely say that she requires one more r plus equal 1. But an interesting thing about this, if we if the r crosses the max r, okay, if r is greater than max r, she will never able to eat the bananas anyways. So return false at this point. So we are doing a early return. We are not going to compute for all the piles. And outside, we are just going to check if the r is less than or equal to the maximum r we have. Okay. So the canit function completes like this. And the minimum speed function completes like this. Let's just run this out if you are able to run it out. Yeah. So as you can see, it is accepted, but it is not an optimal solution for this. Let's just run it out. Okay. Okay. So this works, but what if we submit this code? What will happen? Let's say it's surely going to give you TLE. Yep, it gives you a TLE. It passes the test cases. That means this is a correct code by doing a linear search. Let's just perform binary search on this. So instead of doing a linear search, I'm just going to comment it out. We can do while this is less than e. We find the mid. Mid is equal to s plus e minus s by 2. I generally explain, during explanation, I generally try to keep it simple. So I do s plus e by 2. But in code, we always have to do this. Okay. We check at this point if you are able to eat bananas at this point. Can Coco eat bananas with this speed? That is piles, h, and mid. Mid is the speed at which we are checking if Coco can eat the banana. If she's able to eat at this point, we will search for the better answer. That means we will say that e is equal to mid. We stored the answer in e. We will check if we are able to get the answer. Otherwise, she was not able to eat the bananas. If this is false, that means if this fails, then it will go to the else block. We will say that s is equal to mid plus 1. That means Coco was not able to eat at speed mid. So surely she will require speed more than mid to be valid. Okay, that is it. This is the only change we do, and this is what it is called as binary search on answer. Binary search on answer. Okay, let's just run this code out. Yep, it passes all the test cases again. Let's just submit it out. Yep, it works. Okay, so that is it for the video. If you like it, you know what to do. Bye.